Cardiovascular disease remain as one of the leading causes of mortality around the world. And in order to better understand cardiovascular disease, we need to improve existing vascular models. Bioprinting is an up-and-coming technology where living human cells are mixed with bioinks to 3D print tissue-like three-dimensional structures. However, mimicking the complex architecture of coronary arteries using bioprinting is very challenging. Existing hydrogels compatible with human cells are difficult to handle and print with bioprinters. In a collaboration led by Professor Hashimoto and Professor Tu, we want to find an easier way to fabricate cell-laden vascular constructs. We developed a fabrication technique that uses 3D printed porous molds as templates to cast networks of vasculatures and cell-laden hydrogels. We can control the thickness of the vessel mold. We can create branching networks and even fabricate non-planar hierarchical networks. These methods also allow us to create multi-layered structures, where each layer can be customized either with increased stiffness to improve structural integrity or additives to improve cell compatibility. Animal models are still heavily relied upon for drug development. But given the underlying molecular, cellular, and physiological differences, many drugs fail because toxicity problems do not arise in animal models but appear in human clinical trials. So I do hope in the next decade, more and more technologies will emerge that can help us engineer tissues to mimic organ level functions so that we can effectively use these models to test drugs. These 2D or 3D microphysiological systems should present new opportunities to improve our ability to predict safety and efficacy of new drugs. Of course, more development is required before we can reach a level of standardization and reliability. Creating new and improved biomaterials that are more physiologically relevant is essential for advancing the field of tissue engineering. That is why I hope to remain engaged with MRS in the future, to meet and connect with fellow material researchers and future MRS conferences.